Good afternoon all. The honorable dignitaries and the dais and my genius technocrat friends present here. So I feel privileged to present this paper in this forum. Paper industry towards green manufacturing, and my paper is hydrogen peroxide, a quick solution to rectify foul conditions in activated sludge process. It's not working here. So what is green manufacturing? So green manufacturing is a zero. So what is zero? That means zero resource consumption, zero water, zero coal, and zero impact. If everything is zero, then product would be zero. But our aim is not that to make product zero. We have to produce a product with approved adequate quality, but our target is zero consumption of resources. But is it possible? No way. The perfectness don't say about the practicability, but we have to go to the ideal. Everywhere scientists say that ideal. So what are the ideal conditions, ideal requirement to produce a good product? So that's why the bare minimum requirement of resources we have to utilize. So for green manufacturing, 5 principles are there: that lesser energy consumption, use the least natural resources like water, coal, and all other things, reduce pollution and waste, moderate emission or minimum emission from the chimneys, and recycle, reuse the materials. And this is 360 degree. What is 360 degree? That is the total product cycle, not that resource product, and this is the manufacturing process. After producing that product, the whole life cycle should be a green process. That is the green manufacturing. So this is the picture. This was the previously what was there, that forest is cut down, deforested, then so much smoke is coming out, and the water is not a water, it's completely a domestic drain like that. This was the picture of the paper industry some 50 to 60 years back. But now the scenario has been changed. What Mr. Goyal told, that 80% of mills are using recycled fiber, and out of the rest 20%, 10 to 12% are using agricultural waste, and the rest the virgin fibers. That virgin fiber, that too from agricultural or farm forestry. So we can say this area is totally green, but still no. Because our keynote speaker has opened our eyes that this is not the total green. How to transport this raw material from farm forestry to the factory area still consumes diesel and petroleum products. So they are emitting so many GHG, greenhouse effect gases. So it's not totally green. Still there is a scope to improve. Coming to the next one, you see so much smoke is coming, and now it is moderate. We have controlled. That means we are not preparing paper industry towards green manufacturing. We are on the march, and I hope we crossed the half the way, and we are on the way. And rest part, that water. So we are consuming so much of water and producing effluent, but that effluent, now it is not like that. In our previous session, Mr. Mohammed Salim has given one example that mills are there who has effluent, zero effluent from their mill, and for only 1.4 to 1.8 meter cube of water they are consuming per ton. Perfect. But still, many mills, they are still discharging water. And it has to be there, and whatever natural resources we are drawing from river, that is water, we have to return to the nature again, though exactly not at the same quality, but definitely with a ideal quality with certain norms, which will not harm our nature to such an extent. So this is the common effluent treatment plant diagram. So everybody knows it, that first that grade, then screening, then grade, then primary clarifier and aeration tank, then secondary clarifiers. This aeration tank is the aeration lagoon or activated sludge process. We will concentrate there only. And what is the thing? What Mr. Ganesh Bharti told, that the resources are limited, and at what rate we are consuming, it will be only 50 to 90 years. So by you people, you technocrats' actions, it will linger to 200 years, and I believe it will happen, and not only 200 years, you will find some other way that paper can be made without wood. Maybe it is possible. And second thing, this, what are you doing? Or you are printing, don't print. This is the thing what spread by that electronic media, don't print. If you will print one A4 size paper, then you will consume or you will waste 10 liters of water. Yeah. So still, after 10 years also, the same electronic media people will say, don't print. How? Don't print. Save some fibers for me to manufacture me, so I could be recyclable. So all the mobiles and laptops will be recyclable and not a huge dump. Okay. So the next thing is functions of a activated sludge process. So activated sludge process, they will have flux of active bacteria which will oxidize the COD and BOD, and they will remove all these toxicants, and they need oxygen to continue that metabolic process. And so that's why these organic carbon oxides, they will produce new cells, new bacteria, and carbon dioxide and water will be produced. So the reaction is, you see, organic materials, oxygen, nutrients, they will produce carbon dioxide, water, then new cells, nutrients, energy. Another part is that nitrification and denitrification. Nitrification is that so much of ammonia will be there, so they will be converted to nitrite and then nitrate, and afterwards, during the secondary clarifier phase, denitrification will be there. From that nitrates, again the nitrogen gas will come out and it will escape to the environment, which is not harmful. So there are possibilities that in this aerated lagoon, some septic conditions will happen or some foul things will happen. So in that case, those who have faced that, they can feel how difficult is it. It is just like you are driving a car to your airport and the midway you find that your brake is not working. It is like that. So what happens in this foul condition, that aerobic conditions will fail. Anaerobic conditions will start out. So this nitrification, denitrification may stop. So DO, dissolved oxygen will come to zero or very, very minimum. So all these problems will start again. Lot of foam will be there. And what are the reasons? Reason is that organic overloading, maybe short circuit or short hydraulic detention, maybe overgrowth of SRB, maybe old sludge accumulation, it is your SRT is very high, or some pH shock, or in a temperature shock or a temperature, high temperature particularly in summer season, or there is a partial nitrification. So this is the one case study. So this is the schematic diagram of that plant where it happened, and I will tell you how they have solved it. So this is the control parameters during the normal run. You just highlighted, I have the red things. You see, COD was 70% reduction and BOD reduction was 91.6%, pH was 6.8 to 7.2, and DO was average 0.7. And ML VSS to MLSS ratio you need 0.7. And suddenly this thing happened. And this thing happened in the sense, what is to be done? So much of firefighting was done and how to come out of that situation. And during that period, we have done some microscopic analysis. You see, the top one is ciliates, then rotifers, and another one is, so this is the video you see. This is one rotifer, it is doing another. That one what we have observed. And even we have seen nocardia, that's a filamentous bacteria with septs. So this is the trouble period. You see that COD reduction has come down to 67%, BOD reduction came down to 86%, and pH 6.9 to 7.2. There is no change in pH, but DO has come to 0 to 0.2. And particularly ML VSS to MLSS ratio, you see, came down to 0.5. That means some inorganics are more there rather than that bacteria. What happened? We have tried so many things. We have tried to drain out most of the things because so much of rotten egg smell and fishy smell was coming out. So we have drained out. So once we drained out, then the FM ratio was disturbed. And then we have started adding cow dung to create some fresh bacteria. But still it was not solved. It was very difficult. Then we started adding some sodium hypo to kill some filamentous bacteria. But then we thought, why not hydrogen peroxide? Hydrogen peroxide is utilized as a bacteria killer. So there is a fear that whether it will kill everything and it will spoil. But still we have added in 2-3 pages and finally we succeed. So let us see the DO at aeration tank. You see this is a problematic period. You see DO at 0, but H2O2 running period, you see how the DO has come up. You see that COD and BOD trend. So this is the problematic period when we started hydrogen peroxide. You see where. So hydrogen peroxide where to add? We have tried 4 dosing points. First one is in the lander, incoming lander. Then directly in the diffuse aeration area. And third one in the outside outgoing lander. And finally we have added in the 4th one. That is in the pump, which is feeding to the secondary clarifier, that clicked us. How much dose we have to give? You see, this is the hydrogen peroxide chemistry, how it is decomposes and produces nascent oxygen. This is a source of oxygen. And you see, in 100% concentration, H2O2, it will give 47.04% oxygen from that. We have used 50% concentration peroxide, which can give oxygen up to 23.52%. This is the same calculation, how to use that different concentration of hydrogen peroxide. And you see how the things counter, what have happened. After adding peroxide, what happened? This is the thing. So all these things have, sulfides has been removed. And we have came out of the situation in one overnight. In 8 hours, we have come out. And the only demerit from this one is that it is costly. Otherwise, no demerit, no toxic productions are there. So it is very suitable for green manufacturing to come out of everything to give a good water return to the natural resource. Thank you all.